Hi, good morning, everybody. Thank you for being here today. I'm very excited once again to talk to you about something that's really important to me, and this is how to deliver successful project in using AI technology or machine learning. Today it's going to be a little bit more detailed, so let's use machine learning instead of AI. So before we start, let me talk to you a little bit about myself. My name is Olivier Blais. I'm a co-founder and head of decision science for Moov AI. So what does it mean? What's the difference, frankly, between data science and decision science? So I'll explain you why I decided to do that. Data science, it's how to exploit and use data, while decision science is how to use data and make sure that the decision afterwards is the right one and is really useful to the stakeholders. And that's it. So it's one step further. And this is why it's really important to me to use this type of distinction. Okay. At the same time, I'm also chief product officer of Snitch AI. So Snitch AI is a quality evaluation platform for machine learning systems. And lastly, I'm also working on the ISO standard to develop a technical specification on quality evaluation guidelines for AI systems. So I won't talk a lot about that today, but if you have any question about how to evaluate the quality in particular of a model and how to go a little bit deeper, just let me know and I'll be more than happy to talk to you. Probably too much about that. I'm so passionate by the quality of ML systems. So first of all, and yesterday I talked a little bit about this during my in my previous talk. So this is disastrous right now. 85% of every projects are not delivering the right outcome. Okay, and here you can turn this metric upside down or this stat upside down. And Gartner has also said something very similar. They said that I think it was 80% of the AI systems are not deployed. So here they're not deployed, or if they're deployed, most of the deployed solution are not even delivering the right outcome. So this is disastrous. And today we'll talk about a different solution on how to avoid that being carried over and once again solve this problem so that every dollar you invest in developing machine learning, so it's not just dollar, but you invest in a team, you invest in innovation. People want to develop things that work. I've seen a lot of situations where the team, the data science team, were trying so much to make things work, but there was alignment problems. There were a lot of problems that we'll talk today, and they just all quit because it's not very motivating to work on projects that don't deliver the right outcomes. So first, let's go back in terms of maturity, because this is often the problem. And let's think about what should be the strategy, okay? Because usually we tend to want to skip steps, want to say, you know what, AI, it's useful, like everybody talk about it, buzzword, blah, blah, blah. So, but other than the buzzwords, you need to be prepared. You need to be okay with an AI solution using machine learning. And here, by the way, I think you realize that I'm going to mix a lot machine learning and AI. So here by definition, or let's say, here's my definition, because I'll simplifying it for you. If AI is a car, machine learning is the engine of that car. Okay, as simple as that for now. So if the company wants to build wants to have AI, just like, oh, I want to have AI for my company, but they're not prepared because they're not mature enough. Next thing you know, it's going to fail probably. So here, let's review the different stages of maturity in data science. Okay, so it all starts with the capability to collect and store the data. We're not even talking about about the analysis capabilities for now. Just storing the data and convincing the business that they need to start using data. They need to start having the data if they want to do something about it. Usually it's going to be legal purpose. Oh, legally you need to keep your financial data. Legally you need to keep your operational data, etc. Okay, so this is important because as soon as people start capturing the data, they understand that it's not a walk in the park. It's complicated. So what type of data do you want to capture? Data quality, you're starting to investigate on that. But if it's just a data dump or you capture everything into Excel, it's going to be a stretch to think that you can take a bunch of Excel spreadsheets or just a massive data dump that has never been reviewed and transform that into a useful machine learning project or an AI project. So here, this is food for thought, and this is usually you don't want to jump into AI right away, okay? Because it's going to be a recipe for spending money. So instead, you need to progress to the next level, and the next level it's starting to build analytics capabilities. Okay, so here we say why. So it's being able to answer the question, why does something happen in the organization? So if you store operational data, let's say, okay, so you're at step one, so you started to store operational data. So step two is having a team or having people in place who want to answer business question. So, okay, based on my operational level, so what could have been the problem? Did I have problem with my machine? Did I have some bottleneck that I can identify from the data? So here, this is a major step because it's finding people who are a little bit more advanced analytically. So not only do they need to find this type of answer, so you identify usefulness for type of analysis, but also people, they start relying a little bit more on the data that they collect. So it's not just intuition. So they have the desire to use data to answer business problems. This is very important for adoption. But also, you start realizing quickly that data quality is an art. So it's not when you collect the data, it's one thing, but then analyzing the data, you say, okay, my data is flawed, my data is incomplete, etc. And this is a stage where you start fixing data quality so that you can have better analysis afterwards. And then there's a chasm. So you could have the best dashboard in the industry. You could have a big BI team. There will still be a chasm right there. If you want to go further, you need to work on your capability to predict the future. Okay, it's one thing to analyze what happened in the past. Why did it happen? You can identify what happened in the past and say, you know what? I'll try to fix that. I'll try to adjust my strategy going forward. But to have a machine do it for you, to have an algorithm, this is a stretch for a lot of businesses and a lot of people. predict the future. It's something that we're told very young that is impossible. It's a little bit like flying. People cannot fly. You cannot predict the future. But generally speaking, you're right, you cannot predict the future, but you're able to use statistical algorithms and machine learning to help you forecast more properly. And this is where you need to work. So this is how you need to work on your problems, because if you're not trying to predict what's going to happen, you're going to be left out because other companies do it too. Okay, so step 3 is exactly that. It's create the capabilities to predict what will happen in the future. So here, if we come back to our example, if you're measuring your operations and you have created analysis on identifying bottleneck, now because you have information about bottleneck from the past, you could be able to predict if other bottleneck are about to happen based on the type of project, based on the staffing, based on the machine status. So you could predict that, and you could have a clear view on what's going to happen. So this is useful because it gives you a lead time to adjust yourself. Then step 4 goes further than that. So not only are you able to plan what's going to happen, but you're also going to propose, the machine is going to propose a solution, okay? So this is further because it even removes further the human out of the equation. So you not only would you be able to predict that there's a bottleneck, but you could also, the model or the system could propose a solution that solves this bottleneck. So saying, you know what, if you work on this order, or if you work on this part that you're building, you're going to have a bottleneck. So instead, work on that other order. So you could minimize the impact of that. So here it's not a human that would come up with this solution, but it's the AI system. And then finally, the holy grail would be to have a fully autonomous system. So here, clearly, this is not necessarily what everybody wants, and I don't suggest that you push it to the end, and instead you should deliver iteratively. So at first, you work on why did it happen, and these analytics capabilities. After that, you start creating some forecasts and some predictive capabilities. And then when they're satisfied with the forecast, you then generate solution and prescriptive analytics. So you propose solution and you have a human validating those solutions. And then whenever the human in the loop is satisfied with what is there, then you can think about full automation. And here also, just to put things in perspective, most people are at the beginning of the journey. So this is okay. And people, they want to be more involved. They think that they're ready to be there, but just don't overestimate people's maturity, because otherwise you're going to have to deal with maturity problem along the project, and this is important to just realize it at the beginning. So now that we talked about maturity, let's talk about a clear evaluation of the projects, because this is also another problem. When you work on a project, you could try to hit a grand slam, a project that is the most innovative project ever, or you could just work on a smaller project that delivers also some benefits and is useful. So know that there are different ways of analyzing the different opportunities. And here, the right way to build your machine learning is by just having a clear view of the impact of what you're about to build or what do you want to build, and also what's the complexity, and then take the decision based on those two factors. So when I'm talking about complexity, those are the themes that I'm always looking for. So first, data. Data is critical. I think I said it, everybody says it, so this is okay. I think you start to understand. But here, you need to evaluate every time if you have data, if you have enough data, if you have data of good quality. Are you allowed to use the data for machine learning? Do you have enough signals to be able to predict something? So do you have the factors that can help you predict? It's a good question. So this is, I think this is the most basic complexity factor, okay? If you have enough data and your data is of good quality, and for sure at the beginning, you won't be able to answer for sure, but you can at least, you can at least estimate if it seems like you have the data to undertake a project. Because when you evaluate all of the different ideas that you have, some idea you won't have any data, or the data is just available, using external source because you don't capture any data. This should not be a first project. This should be probably pushed in the future. While a project that has some quantity and some quality of data that you own and you master should be prioritized. Then another problem is the task. And the task, this is something that you need to have experience in machine learning or data science. But are you asking too much out of your data set, out of your problem that you try to resolve? If you're trying to automate your supply chain, you're asking too much out of one system. If you're trying to predict the demand for some SKUs, oh, okay, now you're talking. Now it's more, you can control, and now the task, it's a little bit easier and more realistic to achieve. So kudos, you're on the right direction there. The last two ones, usually they're put on the side, and they shouldn't. So here, adoption is critical. So is this a solution that would be used by the end users? So here, so what's the cost of a bad decision? Answer that. Is this, so a bad decision out of the system, would it cost someone's job? Would it impact, what's the impact on the organization? So if the impact is really important, it's probably not a smart first project. It's probably a project that you push in the future once you start mastering a little bit more AI systems. And then finally, the integration. So where does the project, where does the project reside at the end? So is this a dashboard? So you create a commodity price prediction model, and at the end, you create a dashboard that can be consumed by the end users. So this is fairly easy. Or is it a complex SAP integration? Because this is where you need to consume your replenishment opportunities that have been identified by an AI system. This is very complex. And the more complex it is, the more the bigger the project, and probably you wouldn't invest in an SAP integration yet. You probably would like you probably would prefer a dashboard integration. So then after that, when you have identified the complexity, you would also need to identify the impact. So how do you identify the impact? Just look at your business objectives. So what is considered what is considered a better initiative based on your business objective? So if your company is focusing more on cost reduction than revenue generation, let's say you're in a very mature industry, and it's more important to be operationally efficient. So probably those initiatives will have a stronger impact on the business. And so this is how you are able to identify the most important projects. So here you look at the impact, you look at the complexity, and usually what I would suggest is to work on quick wins first. Okay, understand sometimes we might be tempted to work on the big bets, the high impact, the high complexity, high impact. But because it's so hard to deliver well an AI project, please just work on project with a good impact and a very small complexity, so that you're able to have a project very quickly, because it's going to be a simple project, and then you'll be able to get adoption and work on other projects afterwards. While working on like those big impact, big reward that are more complex, they might take so long to deliver. You might have a hard time getting traction. So this is also food for thought, but I strongly suggest to work on the quick wins there. Excellent. So now that we talked about selecting a project, and let's say we have selecting the right project. So how does machine learning work? And here I think people they tend to understand how it works, but let's just go back to it one more time. So when you build your AI model, and by the way, how does machine learning work? So now we're talking about algorithms and stuff. So we're talking about the engine there. So how does machine learning work? Is that you're using statistical method to be able to identify trend in the past that can be leveraged to predict the future. That's it. As simple as that. You might have people who say, yeah, but this is using neural networks, and then they try to explain you that. But at the end of the day, you have data in the past, you have statistical methods that are able to identify trends, and then hopefully the statistical methods are good enough so that the trends that are identified can be used to predict the future. And here, this is what you try at the first step. So you use the past information, you test different configuration, different method. Those statistical method that I talked about, those are the algorithms. So you just test different algorithms, you test different configuration, different option, and then you see what happens. So sometimes you're able to have a performance model. So a model is the algorithm that is applied to your problem. So sometimes you have a performance model, sometimes you don't. So this is where then you need to select the best model. When you selected the best model, and this is something that's really important and often forgotten, but you need to validate it once again. Okay, sometime in machine learning, we'll talk about like the test data set. So a test data set or back testing is also another term that you might have heard. So those data sets, they're data sets that are not used by the team while training, while testing different configuration. It's really new. So let's give you an example. If you build an AI-based forecast, so you might try a forecast for like the past 4 years, but you keep the last 2 months. You put it in your back pocket, okay? So you're not using the last 2 months to train and to select the best model. But then you want to validate if it actually worked, because the trend in the past might not be used in the future or useful in the future. So this is why you need to validate at the end of the day that you are able to use whatever you created on unseen data and have the right results. So this is why you come back with your test data set and you do some back testing. And then when it works, this is when you decide to deploy your model into a valid solution. And then here, this is a different graph, by the way. Whatever I just talked about. So this is the machine learning methodology, but this should not be your project methodology, okay? Your model should then become a solution. And here, the way we suggest is to use these steps. So this is what Moov AI is using, and we've been having a lot of success with that. So at first, you have the project liftoff. This is where you decide. This is where you decide what the vision are, what the objective should be, what the team is, etc. Okay, this is your project plan that you're going to build. Then you will work on something we call the MVM, the minimum viable model. So this is a end-to-end project, so a model, and this model is going to validate that it works. Why I'm not using proof of concept? Because a proof of concept, usually you're going to throw it in the garbage afterwards. Here, I'm talking about investing a little bit more money to be able to have an end-to-end solution that can be reused almost as is, okay, in a solution. So when you have validated that it worked, then you're working on a MVP, minimum viable product. So here, this is the full solution, or we'll talk about it later, but a system. So the AI system is not just a model, and we'll talk about it. But this here, at the end of MVP, you should have built a model that is sitting in infrastructure and can be consumed by end users. Okay, and this is where it all starts. So you first have something you call a beta, and the beta version is usually used during beta testing. Okay, so you test, so it's not full-blown delivery yet, but end users are testing the solution and they're confirming if it works or not. Okay, they validate that the solution is delivering good results, and also on the adoption, it's really important. And then after that, you implement the final feedback, and hey, voila, you have a solution that is working in production. So when I said that an AI solution is not just the model, here this comes from Google, okay, and this is often the error that we're making. We're focusing so much on the AI code, on the model, that we forget all of the other parts. But at the end, an AI solution or an AI system, this is like the infrastructure. This is the data pipeline that is able to push data in real time to the solution to generate those real-time prediction, for instance. The monitoring solution, the dashboards, the quality, the quality assessment, quality assurance, like software engineering is key for a solution, and we often tend to forget that. So make sure that you include this into your project. Rule of thumb, and you would be, I think you will really be surprised, but the modeling phase should be around 20 to 25% of the time you invest in your solution. The rest, it's all working on database, working on the operationalization of the solution, and building like the system that can support the model. So here, now that we talked about like the full solution, the full system, so what do we need to validate before we can confirm that we have a good project? So first, you need to validate that the model works well. So here, I'll give you some guidelines, and let me know if you want to talk about it later. This is something that I'm really keen about, but generally speaking, you will need to validate two things. And here you'll understand that I'm talking very generally, but there are a lot of subset that we need to dig down. So here, the big team is at first the functional capability, okay, of the model. So here, in other words, so is the model useful? So is the model able to generate good prediction on the data that has been seen? So is the model able to extrapolate on new data? Because it can be very good in the past, but in the future, if data changes a little bit, or if trends are updating just a little bit, maybe the model is not able to generate useful predictions. This is a good question, and here I'm touching a little bit into robustness. But is the model robust to noise? So let's say you have a little bit of noise or like noisy signals. Is the model going to be useful? Also, we have ethical risk mitigation. Here, this is not an easy one, but this is something that you need to deal with. So ethical risk mitigation. So at first here, just to explain you, like when we talk about ethics is so important, but it's hard to say, oh, you know, my model is ethical. So instead, how I suggest you to deal with ethics is to identify any risks that could be related to ethics, and then just try to mitigate all of those risks. So common risk in terms of ethic would be the fairness of the model, would be the unfair, unjustified discrimination. Okay, so unjustified discrimination could be that in some situation, some people are getting discriminated, but there's no reason, because people were doing it intuitively in some ways. Then the machine learning is learning those rules and just reapplying them blindly. So you might want to deal with this. Also, accountability. So are people, so when you are going to automate decision making, so you will need to make sure that people understand that they need to remain accountable for the decision of the machine learning. So if you're a bank and you generate prediction for loan authorization, if you refuse people, but the loan or the team in place at the bank will still be responsible and accountable for those loan refusal. So they need to be aware of that. So those are examples, and I suggest you to look into that. But those strategy, they need to be they need to be implemented, or let's say instead the different element or the different risk, they need to be seen as risk and they need to be mitigated. Okay, you review that it's not the case, or if it's a case that you have something that prevent this ethical risk to happen, and then after that your it means that your model is a model that mitigates ethics risks. So this is for model, but then for the system, here I'll talk loosely about efficiency. So if you build a recommender engine, for instance, is the system able to generate prediction in less than a second? Okay. Is the system able to generate recommendation for potentially hundreds of thousands of users that might join simultaneously? So those are questions that you need to answer. So here, in terms of testing, I suggest you to think about stress tests, about load tests. This is software engineering. So here, I'm suggesting you to deal with software engineers to be able to answer and validate that your system is of good quality from a efficiency standpoint. Also, security, it's not because it's supposed to be an automated system that you cannot have created security breach. So please also have a security review of your system. You want to avoid having personal information open to anybody. And this is especially true when you try to hack your way through, the end. It's not because you're trying to deliver a first project quickly that you can allow some security breach into your system. So please work on that. And then finally, the last portion is about the utilization from the end users. So first, if you're talking about usability, is the system usable? So if you create a dashboard, is this understood? So the usability is how people are going to use the output. So at first, is the dashboard the right medium or not? Maybe you create a JSON that sits into SAP and you spend a lot of time integrating into SAP. But at the end of the day, from a usability standpoint, probably that the end user might just want to have a dashboard. And so it fails the usability test. And then finally, on the understanding part, how do you make sure that the end user can audit the prediction and understand the most important drivers explaining the decision? So those are also things that are a necessity, because you want people to advocate for the system and use it, but they probably will not use it if it's not understood. So here, I understand I talked about a lot of different validations. So where should it be done? So it should be done at 3 different places in your project lifecycle. So you see here at the beginning when you build your ML, so you access data, you create a model, you then refine the model with new data, etc. So here, this is where you should, and I guess it's not an official gate, but it's debugging. I mean, this is useful. So your validation capabilities can really be useful to debug the system, to make sure that the system that is created is a system that's useful. Then at the end, so when the development has started to happen, so you want a business validation. So even before you created the full system, is the model good enough for the business? And then at the end, when the system is fully functional, so is this what the business wants? So at the end, this should be what gives you the the permission to go forward into production. And then when it's in production, so when it's operationalized, so here you will want to monitor. So the monitoring of the solution in production is paramount. It's critical because it evolves and it evolves over time, and it's not true that you set it and then you can forget it. In fact, here what we often see is that over time. So here, if I walk you through the life cycle of the project, so at the beginning, so when you start creating your model, because we suggest you to use iterative mode, you'll see that the performance will slowly increase over time. And then when you'll be near the MVP, it's where the solution will be very, very good. Okay. But once it's in production, it's downhill from there. So because it's going to degrade, if you change the data, there will always be something. It could be elegant, like, oh, the consumer trends is changing. It could be some violent shifts like COVID-19, for instance. It changed everything into 1 week. Or it could be just an IT mess up where like the data just changed a little bit because of a new system in place. But you need to be prepared when those changes happen because it's going to degrade the solution. So you need to have a mechanism in place that not only validate the model, but is able to retrain and redeploy your model and redeploy the full solution. So on that note, thank you very much for your time. And I hope that your next project is going to be a very successful one. And I'll be waiting for a question. Thank you.